Look at that hole. Okay, so before we found the volume of this whole solid, but now we're going to consider this hole that's in the middle of it. So if you guys wanted to take out volume, that'd simply be subtraction. But how do we find what we're taking out? First, let's write down what the volume of the whole solid would be. Remember, to find the volume using cross sections, what we're going to do is we're going to find the area function of the disk and then plug it into our integral from a to b, and from a to b would be from 2 to 9. So this would be the volume of the whole shape. I got to put dx right here. All right, so I have to have a of x right here. So what is a of x? Well, a of n is the area of a disk. What is the area of a disk? It is pi r squared, or n squared. Okay, what is n in this case in terms of x? To find n, we did this already. You go top minus the bottom function. The top function is the square root of x. The bottom function is -2, and so that is n. So when I get a of y, this is a of x, this is what we did yesterday. I plug in the n into the a. So I get pi, and then I have the square root of x plus 2 squared. All right, so that's my a of x. So I plug it in right here. I have pi times the square root of x plus 2 squared. And we're taking the integral of that whole thing. Now we could take this pi out because he's a scalar, but this is how we're going to leave it. This is how you find the volume of the whole thing if there was no hole. We did that yesterday. So now what we have to do is we have to take away the inside.
Yeah.
Okay, now the inside still goes from 2 to 9. But how do we find the volume of this cylinder thing on the inside? Now this is kind of interesting because you don't even have to use calculus to solve this. You guys know a formula to find the volume of a cylinder. You guys can use regular geometry. I'm going to use calculus, but if you wanted to, you could just use regular geometry. How do we find the volume of a cylinder? In geometry, you know it's, whoa, that's a big A. Yes. You find the area of the base, which is pi r squared, and you multiply it times the height. Okay, we're going to do calculus for the height. Okay, the pi r squared is going to stay the same. So we have a different a for the inside. So let's find that really quick. We have a of n. It would still be, oh man, it's actually the same, pi n squared, because pi r squared, so that stays the same. But we got to define the n. What is the n in this picture? How do we find the radius of these circles, these discs? I mean, you guys know what it is. Yeah, it's 2. Okay, I'm going to show you guys, or talk about it as if it was complicated. You take the top function minus the bottom function. What is the function for this line right here? Is y equals 0. So this line right here that goes all the way across, the function for that is y equals 0. And what's the function for this line? Y equals -2. And if we go 0 minus -2, what do you get? You get positive 2. 0 minus -2 equals positive 2. So your n is always 2. So if I plug that into my function, we get 2 squared. So it's a constant area. Ooh, this is a constant area, 4 pi. 4 pi, it's our constant area. Now how do we do the height with calculus? We do this integral. So we're going to take this a of x and plug it in this integral, just like we took this a of x and plugged it into this integral. So we go 4 pi dx. And that's it. That's what you get. Oh yeah, if you plug this into the calculator, you'll get your answer.
And then you subtract that from the first answer?
Yeah. So this would be the volume of the inside cylinder, and this is the volume of the whole thing. So you can plug this in your calculator and you get your answer. But before I plug in my calculator, let me show you guys how you can simplify it. Because it says subtraction, and because we have the same interval, we can just go the interval from 2 to 9, and then we have our pi times rad x plus 2 squared minus 4 pi, and we can put parentheses around this whole thing, dx. And that would give you the volume of just that opening, or the solid, which is on the outside because it takes away the inside. So after you plug that to your calculator, you get 323.451. We're going to say cubic units. We don't have exact units here, so, or like a measurement like centimeters or anything like that. So you just write that out.